hopefully you remember how to do it. You had the
Probably have
practice
2
problems with the sheet. Make sure you get that out.
We're having,
You know the deal, yeah.
we're having.
I'll come back, yeah.
Oh, I got it.
This stuff is gonna be on the quizzes now instead of that.
Oh, that works. Okay. You just get
They're
a
both right, I know
sheet,
they
is
are.
that right?
Actually, that
I
was-
know,
that
I
was
just,
yours.
I was too lazy.
Come back.
He doesn't have a sheet.
I
Okay.
already did it.
I know, I'm just kidding.
Alright, you still have to have it, that's why I can check it. Like every day, so I remember, like, I remember I checked it all yesterday, but you don't wanna rely on just, oh, I checked it too yesterday. Make sure you always bring it, even if you do extra work, like sometimes in junior high they'll work ahead, and so they'll tell me, oh, you saw it. No, make sure you bring it, cause I'm not gonna remember the next day, cause there's a bunch of you, and I have to teach 5 classes, and I'm not gonna remember who showed me what, which work when. So make sure you always have it. How's it going? Are you finding it though?
Looking for it.
Okay, Ethan, let's go over your
How
9
many
and
questions were there, sorry?
okay, it was the application number 1 saying is it combination, decomposition, that
Okay.
section, so there should be 4 questions, and then you have your worksheet. So, sure you go get it. Alright, what do you have for number 9, Ethan?
S8 plus 8O2 arrow 8 SO2.
Good job, so it's one of the octosulfide, so that's a bunch of them, and then 8 of the oxygen I can't talk, I do it at the same time. So, it'll be sulfur 8 plus 8 dioxygen yields 8 SO2. Alright, the next one, Ethan, what you got for that one?
Fe plus 2AgNO3.
What is that?
What?
AgNO3. You should be able to know the name for that.
Silver nitrate.
Good job.
Fe, iron nitrate.
Good job.
Of what you do. Yeah, okay, and then plus, 2Ag.
What's Ag?
Silver.
Alright, yes, and that is the correct answer for it.
Correct.
Alright, how's it going, Chris? You finding it?
Yeah, I'm going through page by page now.
Okay.
I know I did, I remember doing it.
I remember seeing you do it, but you gotta have it in class, so keep looking for
You
it.
did it on the sheet?
What?
The sheet.
Huh?
Oh, the homework has it in the displacement?
Yeah.
Alright, so let's go over the answers for
I got it.
You got it? Alright. Alright, you have your worksheet?
Let me try to find it.
Don't tell me it's in there.
Yay!
Why are you laughing so much, Chris?
Oh my goodness, this man put it in the thing.
Yay!
I
Alright.
knew where this was.
I know. I figured we did.
Let me get over there.
Do I need to keep this out?
You don't have to, because I don't know the answer, but you can. I know that you got the right already. So you might move on from
I
that.
feel smart.
Good job.
Are we
Alright,
gonna do like a little review before we get the quiz over?
alright.
Listen.
So, classify each of the sections in question, in the application number 1 as combination, decomposition, single displacement, double displacement. Alright, if it's combination, what does that mean? What's happening?
2 teams coming together to make 1 team.
Yes, so it's 2 elements or 2 compounds coming together to make 1 substance. What if it's decomposition?
It's where they're splitting apart.
Yeah, so you have 1 substance and it's splitting apart into 2. Alright, single displacement.
One thing is splitting apart, being left aside like a piece of crap.
That's right. So basically, one element is taking the spot of another one in the compound and it's kicking the other one to the curb. Alright, double displacement. What does that mean?
Both of them are switched, like there's 2 and then they switch. One of them
Yep.
switches.
So it's basically both of them are swapping partners. Alright, so letter A then, or A, is what type of reaction then? Ethan.
Combination.
Good job. So 2 things come together to make 1.
Like the pizza.
Alright, what is, distracted. Alright, what is B then?
DD.
What is that?
Double
Why did you use your double displacement?
displacement.
Good job. Double displacement. Alright, letter C, Ethan.
Double displacement.
Is it?
Single.
Yeah, it's single displacement. So make sure the condition, okay, that you have 1 substance is taking the place of another one, and that other element is being kicked off. Alright, last one. Which is that?
Single.
Single displacement?
Single.
What is that?
What?
What is that?
Single displacement.
You sure? No, actually. Ethan.
Wait, number 4.
D.
He said single?
You said single displacement.
That's not double?
Not double.
It's combination.
Combination.
No?
Disparagement.
Look at it! Go look at it!
Disparagement.
Look over, okay, I had my page in the wrong spot. Over on page 52. Alright, you
This
have.
combination.
Is that how you say this?
Discomposition.
Yeah.
Decomposition.
So, right off the side, to make sure Jamie and Quentin can still see it. So, you have, in that reaction, you have CaCl3, which is a side note. What is this?
Calcium carbonate.
Calcium carbonate that it is breaking apart into calcium chloride and oxygen. So you start off with one substance and it's breaking apart into two. So just make sure, I know it looks a little weird how this one's still a compound. So make sure that you know it's starting with something. What would this one be as a side note? This was not part of your homework in this part, but what would that be, right?
Sulfate.
Oh, okay, like what do we call this whole reaction? Would it be combination, decomposition?
Combination.
Combination? What would this one be?
Double displacement.
This one is a compound that's swapping out its partner with another compound.
That's single displacement.
Good job, because I start with one substance. I have a cation and an anion, and so this substance is basically stealing the partner and leaving off poor silver by
Well, it took me
itself.
3 tries. I don't know. That's a good percentage. That's seven.
But keep in mind, when's that quiz over this?
Monday.
Monday. So make sure
Easy.
that you're looking at it. Should be easy. It should be real easy because you're just matching, saying it's this, it's this, it's this. But if you don't know them,
Matching. It's matching.
it is matching. But I mean, or multiple choice, because there's literally only 4 options that you're choosing over and over and over
So I have a
again.
question. Is
Okay.
the quiz that you're about to give us, is it like this?
A lot of it, yes. Not
Some
all
of it's
but it is-
reactants and products.
Because some of it is terms. Because, like for example, what do you call
Did I tell you?
what do you call the left side of the chemical equation?
The reactant.
Yes. What do you call the right
She
side?
was like,
I forgot which right word it
she
is.
was like, what?
Products. What does the arrow mean?
Into.
Yeah, yield technically for it. But
Yield,
it's
right.
yield or it produces. All right. What is the law that says if you have a certain mass of
Concentration mass.
Law of conservation of mass, yeah, you insert mass on one side or number, you have the equal mass on the other, but it's focusing on mass, so it's the law of conservation of mass. What do we call this with how we write them out? What is a symbolic representation of a chemical reaction?
Yeah, so
Chemical
Imperialic formula?
Like, what do we
Chemical
call,
formula.
like, what do I call
Chemical
this?
reaction.
Chemical reaction, or a chemical equation, technically
Don't
how you
do
write
it,
them
don't
out.
do
So chemical equation, so what's the term, Chris?
Chemical equation.
Chemical equation that represents the chemical
So
reaction.
if you wrote chemical reaction, we get half.
Chemical
So
equation.
chemical equation is whenever like you're like an equation in math, is how you write it out. So you're writing out the chemical reaction. Alright.
Just a second. I just want to say,
911, what's your emergency? Yeah, Ethan's taking forever.
Okay, you could study too. This quiz typically takes a little bit longer. Because you're balancing, so it takes an average about 10
chemical
to
changes
15.
caused by collisions.
That's
Yeah,
why I
chemical-
said
reactions.
That's chemical reactions, and
And
chemical equation is the
a
written
symbiotic
version.
representation of the chemical reaction.
That's why it takes me to complete a test.
Alright, so anyone have any questions about chemical reaction, chemical equation, reactants, products, law of conservation of mass?
Can I use a pencil so I can erase stuff?
Yes, you may use
Oh,
a pencil.
thank
so
God.
I told this, Jamie and Quentin, to your parents, you may use a pencil to work it out. No. But you have to circle your final answer in pen, so that I know what your final answer is. I don't want to have.
You have to have a pen out.
Yeah, because you have terms too as well.
So I write the terms in?
Yeah, write your terms in pen, or you can work your calculations in pencil. Alright.
That's right.
So, you can go ahead and take this out now. You get the one that I told Jamie to circle it as well, so I didn't feel like writing down both of yours,
We'll
sorry.
take it out, see it's in the order.
Alright, so read through your directions carefully. You will notice in that entire first section is balancing. So I suggest you go ahead and do the term part really quick at the bottom, so you won't forget to do it later. So go ahead and answer those questions. Write your terms quickly, and then go back and use the remainder of your time to work on the balancing portion for it. So to read carefully, like for number 9 and 10, what's on the left and then what's on the right. So just be careful.
okay if I just like do this so it doesn't confuse me?
Yeah, no, you can scratch it. If you wanna scratch through the states, like the G and the S and the AQ, that's fine. wanna go ahead and take it, because this one takes longer, so that way you can work on something else if you want to. Want to do something longer, you can. But it's only been about 5 minutes, so even if it's another like 10 minutes. You wanna get something, you can, or you can just sit there, that's fine.
Go ahead and play it on you.
Wait, you didn't circle your final answers, we're down here. Yeah, you still have time, Ethan, it's only been about 5 minutes, this one on average takes about 10 to 20. So you still have time, so if you wanna go get something from the locker, Chris, or you're not wasting time, you can, but you just sit there, it's also fine.
Okay, I haven't finished my reading my thing with history.
Okay. What's that?
I'm gonna close the door.
Sure. Yes.
Okay. Are these like one?
Like, what do you mean?
One together.
Alright, it's carbon and oxygen. So you have to decide if you wanna split, if you wanna balance them individually or separate, but it's carbon and oxygen, it's not cobalt.
So I've read 51.
Okay.
10, right?
Yeah.
10's obviously the longest.
Ten's obviously what?
The longest one.
It is a longer one.
I'm assuming that's the one that you think would be.
Not telling you. I read through both, so I know after reading them, you want to think, okay, what are they talking about?
Is it different? I guess it's different for everyone, though, right? Kind of just see, like, tell me
Well,
what's easier.
Alexander Hamilton or whoever wrote it because they use a pseudonym. So Jimmy and Quentin are both in this class, so it's one too. That they're writing under basically a pen name, and they're saying, okay, here's a specific problem that the Constitution will fix. Basically, this is the reason why we set up our government to be this way. All right, 51. Here's another part of our government that we set up to be this way. It's different in ideas. So it just depends on which one. After reading them, thinking which one do we see easier to talk about? We see both forms, like we see both parts in our government today. So once you understand, oh, that's what he's talking about. Oh, yeah, I got it. Then it's straightforward. But you have people to read to understand. Okay, which one is what's he talking about?
I think 10 because you have to write so much. I think to even have.
Alright, what's he talking about? What's he talking about specifically in that one?
In which one?
10.
Okay.
What specific part of the, because remember, that you're saying is what's, because that was the two questions, is what does the founding fathers intend when writing this? Like, for a structured government, how do we see it an example of today?
So,
Well, several
when I
examples.
just quick read through,
Okay.
and they kind of, like, honestly, they kind of sounded a little bit the same.
Because they're both talking about the Constitution, but one of them's addressing a specific aspect of why they set up our government this way, another one is specific saying, here's what we specifically did for this one.
And you can't use both of them, can you?
It'll be clear whenever you read them, whenever you actually sit down and read them properly, and not just you read it, you'll think, oh. And over the next couple of days as we talk about it,
How much time do we have?
you still have about, okay, I can give you about 8 more minutes, so you still have time, cause that'll be 20. Yeah, we'll talk about it over the next couple of days, but it's one of those, I want you to read it for yourself, and I'll probably tell you on Monday specifically, this one is this and this one is this, but you need to be able to read and figure out which, because I can't give you the answers, you have to be able to figure it out for yourself. I can only give you about 5 more minutes.
Alright. I
Got
think
it?
we should finish by then.
Okay.
We learned something new.
Are you what?
Learned something new.
Yep. So I gotta hopefully wrap up material today, Monday, because you see how long this takes, so reviews get slowed down a lot for your test for Wednesday.
Can you guys help homework, sorry.
Ethan needs to focus, I don't want to focus. I would keep it, and I think we could use it to talk about single displacement, double displacement, stuff like that again, under what, under review.
How much time?
About a minute, maybe 2 minutes tops. Sorry, we gotta go eventually. You?
You mark something.
I did.
So I got something wrong.
I'm not telling you. Don't worry about it. We're just for check marks.
I don't number 4.
Number 4 is hard, number 6 is hard, I will tell you that. Okay.
I got number 6, but number 4, I can't.
Which one's
You
number 4?
tried?
Yeah.
Okay, we can't talk about it right now just in case Jamie and Quentin haven't finished it, so remember, you wanna wrap it up as quickly as possible. That was about 20 minutes, so if you needed to fast forward Jamie and Quentin, that was fine, but just make sure that you take it and that you wanna send it to me as soon as possible. Alright, so let's go ahead and let's get into it on page 56 now, talking about mole ratios.
No review.
We reviewed basically before this. Alright, so interpreting chemical reactions. Not really a lot of terms in this section. We've already gone over single displacement, double displacement, combination, decomposition. So make sure you're going over it because your quiz is Monday on it. Alright, interpreting chemical equations. So we talked about this yesterday with the idea of making ammonia. Now, as a scientist, could I physically get 3 molecules of hydrogen, 1 molecule of nitrogen to make 2 molecules of ammonia?
No.
No, because that's too small for me to work with. My eyes can't see that, and I can't work with that. But what can I do to be able to actually measure it out in the lab? What can I do at that point? All right, Chris?
Multiply it by like 1,000.
Okay, not 1,000. We do have a number though that we can basically raise it to.
What is it? Avogadro's number?
Close. Avogadro's number, which is what, Ethan?
6.002, 0.22 times 10 to the 23rd.
Good job. So that means that I have Avogadro's number, or what's the unit we use to represent Avogadro's number? Sorry.
Mole.
Mole. So I could have 1 mole of this substance, 1 mole of this substance, and 1 mole of this substance. So basically I jump everything up Avogadro's number. But rather than multiply 3 times Avogadro's number, because again, I can't sit there and count out 1 atom, 2 atoms, 3 atoms, because remember this is the number of atoms. What can I measure in the lab that is also equals 1 mole? So if I'm looking at grams per mole, because I can measure out grams, how do I figure out grams per mole? Where I can actually work with this now.
Finding the empirical formula.
Okay, well this is the chemical equation, so if I need to get Avogadro's number, but I can't sit there and count out individual moles, what can I look at to figure out how much or how many of a gram should I get to get 1 mole?
The weight.
The weight or the atomic mass units, and just know, okay, add it up together, that'll give me in grams 1 mole of this substance. So that's what your book is talking about. On the bottom of page 56 was showing you how you can actually work up this. Whenever you look at it, the important thing is to notice you have to keep these ratios the same. So if I raise this one by Avogadro's number, or if I raise it to grams per mole, molar mass, then we have to do the same thing for this one and the same thing for that one. So that's what all the little like numbers off the side at the bottom of page 56 in that summary is saying. So where, and they rounded it for, but they're saying, okay, if I want to measure this, I could put it as 6.05 AMUs or just U's, or I could say, okay, grams per mole. So that'll give me Avogadro's number. I can measure out 6 grams of the substance. I can do that in a lab. And for this one, it would be, for this one, I can measure out in 28 AMUs or 28 grams per mole. I can do that in the lab. And the last one, for this one as well, that 34.1, they just rounded, AMUs or grams per mole. So this is how scientists actually work with them in a laboratory setting, because you can't use an individual little molecule, but you can basically Avogadro number, raise it to that. You can't say times that because you're basically doubling everything in it. But this idea, you can raise it and you can actually work with that in the laboratory. And so this allows us to actually work with it at that point. So that's how we interpret it. But the important thing is you have to keep this ratio the same. Whatever you do to one, you have to do it to all the others. We use this in mole ratios. Your book gives you the example of cooking easy peanut butter cookies as a side note. It's just kind of like on page 56. So your book points out that this recipe makes 5 dozen. Well, let's say I want to make 10 dozen. What do I have to do to the recipe? Yeah, multiply everything by 2. So if I want to double it, and it only calls for 1 can of sweetened condensed milk. How many cans of sweetened condensed milk do I need?
2.
2. If it calls for 2 cups of biscuit baking mix, how many cups do I need?
694.
4. I was going to say 3. So 4. Alright, so if I need 3/4 cup peanut butter, that would be, this is kind of a hard one.
3/4 you said?
Yeah.
6/8.
Nope,
No!
That's it?
No, you tried. Alright, so it's 6/4, which becomes what?
Wait, you said what?
Okay, so my original recipe calls for 3/4, so if I double it, it becomes 6/4, which is?
1 2/3.
Close.
1 and 2.
This has been a while since we've done this math, I know.
I know. 1 and 2/4.
Yep, so 1.5 basically for it. Alright, but yeah, so you have the right idea, but it's the idea of I need to double it. But again, since we're looking with measuring cups, it's the 3 times 2, so 6/4, so 1.5 cups. Alright, and then if I need 1 teaspoon of vanilla extract, how many teaspoons do I need? 2. Alright, so it seems easy, but let's say I need double amount of ammonia. But this recipe of this chemical equation calls for only 2, but let's say I want to make 4 moles or 4 molecules of ammonia. Wait, so how many molecules of hydrogen would I need? 6. Alright, how many moles of dinitrogen would I need? Alright, so you don't have any questions about about how to do that is your book's pointing out this is one reason why we can convert, is because scientists want to know, okay, if I start with so many grams of a substance or so many moles, how many can I make before I run out? Okay.
We've done actually like working out math.
We're gonna work out math in just a second. But anyone have any questions about the idea of mole ratios? But you can't say just change a mole ratio, because of this ratio of 3 to 1 to 2. That's why you balance your equation first before you start this. Alright, anyone have any questions about how to do that? Alright, well, let's look at the practice. Your book gives you this one as the practice problem. So how many moles of ammonia can be produced by reacting 4.2 moles of hydrogen? So we're going to erase these measurements right now. But let's say you have a scientist. He doesn't have a whole number. He has 4.2 moles. Now, he wants to know, okay, well, I don't have a whole number, but I have this much. I'm going to react it until I run out. So, how would I set this up? So he says, okay, you have to go back to dimensional analysis to figure this out. So everyone remember what dimensional analysis is?
The analysis of dimension.
Okay, how do I set it up? I know. Alright, so
being stupid. I'm like,
you might remember it from this now. With the idea of, okay, I have to convert from one to the
Oh, I
other.
remember
So
this.
it's not a straightforward ratio with the idea of I have a whole number. So you have to set up this way to figure out how do I set this up. Alright, so since I'm starting off with 4.2 moles of hydrogen, what goes down here then?
4.2.
What unit?
Hydrogen.
Alright, moles of hydrogen. Alright, you have to use the balance equation to figure out, okay, so I have this many moles of hydrogen, I have to figure out what's the mole ratio between the substance that I'm starting with and the substance that I want to go to. So how many moles of hydrogen do I need in this balance equation?
It's 3, so 6.
Nope, so just
3.
3. So according to this recipe, I have to have 3 moles of dihydrogen for every how many moles of ammonia? I can't see that.
2.
2. So 2 moles of ammonia. And so that's how you set this up. Now, if there's a 3 in the bottom and a 2 in the top, what does that mean?
2/3.
Alright, for working this out, I take my 4.2 and what do?
Times 2.
Times 2 and then?
Divided by 2.
There you go! Alright, type that in so you go practice with this.
Without our calculator.
Then you gotta go to your locker and get one.
See, everyone would make fun of post. Everyone would make fun of me for that pink, that pink
But we're
calculator.
Christian school.
We're in Christian school. It's breast cancer awareness. Too much for now.
See what the problem is with this thing? But, you know.
So wait, what are we doing? I'm joking. I'm joking.
Okay.
2.8.
2.8.
Alright, good job. Now keep in mind, since these are whole numbers, you don't worry about these because they are the coefficients. So according to for sig fig, if this one starts with 2, your answer has to have how many?
2.
Yep, so 2.8 moles of ammonia. That's alright, you don't have any questions about how to solve that.
That's how many moles were left out of 3 moles in Russia.
Alright, do you have any questions about how to solve that? Alright, so your book also introduces the term of a limiting reactant. Let's say I want to make my peanut butter cookies and the recipe calls for 2 cups of biscuit mix, but I only have 1.5. So can I make my 5 dozen cookies that I want to make? Ethan,
Yes. Yes.
No.
Yes, you can.
What?
I can make full 5 dozen cookies?
Yeah, you just make it small.
Okay, well, assuming that I have to keep
That's
them
big
the
brain.
same
That's
size,
big brain.
in the same size, could I make my 5 dozen cookies?
No.
Yeah. Okay, so that's the idea of the limiting reactant. That which one will you run out first? Like if you need 2 eggs to make, trying to think. Like I like to make oatmeal cookies, and the recipe that I use requires 1 egg, and I always double it. But let's say though that I need 2 eggs to make my oatmeal chocolate chip cookies because I like them, but I only have 1 egg.
Oh,
Can I-
chocolate chip.
Yep. I don't like raisins, so I put chocolate chips in them instead.
Raisins are just dry grapes.
I know. It's
Raisins
chocolate
are
chips.
nasty.
Okay, we gotta keep moving on. Okay, so if I want to make, if I want to double my batch of cookies, but I only have 1 egg, can I double my batch of cookies, Ethan?
No.
Why?
This is insulting right
Because
now.
you only have 1 hand.
Yeah, so that's the limiting reactant. I might have enough of everything else. I have plenty of chocolate chips, I have plenty of oatmeal mix, I have plenty of butter, but I only have 1 egg. so I can't make it. So that's the limiting reactant. So make a note of that. I know this seems really basic, just make a note for it. The reactant that determines the amount of product to form is a limiting reactant. So you can tell, I'm gonna run out of this substance first. That's the limiting reactant. Your book tries to describe it to you as the reactant that gives a small amount of product is a limiting reactant. Okay, it's basically just looking at it and saying, okay, you want to see, okay, if my reaction just goes, which one will I run out of first? So let's say I have 9 moles of dihydrogen and I have 5 moles of dinitrogen. Which one will I run out of first if I just let this go? Which one is the limiting reactant?
Nitrogen, obviously.
The nitrogen?
Yes.
Why?
There's just less numbers.
Alright, so so if I let this one, we'll say 1 time. So I use how many moles here?
6.
Okay, if I let this run 1 time, how many moles?
3.
3. If I let this run 1 time, how many moles? 1. Alright, so I now have 6, and I now have 4.
I'll show y'all later.
There you go. Alright, so I run it through a 2nd time. How many moles have I used? How many moles do I use?
3.
How many moles do I use?
1.
Alright, I have 3 left. Nope.
No, you have 2 left.
I have 2 left, and I have 3 left. I run it through again. Or can I go through it again?
Just maybe.
No, because I don't have enough of this one anymore. So, in this particular example, which one was the limiting reactant? Chris?
Hydrogen.
Hydrogen. So don't just go, oh, which one's a small amount? You have to look and see, okay, if I run it through 1 time, okay, how many do I have left? How many do I have left? How many do I have left? So don't just assume it's the smaller amount for it. So just be careful of that. Your book tells you to like work it out in math. You could. Or you could just run it through, like how I did, and see how many times can I run through it before I run out. I think that's the easier way. Alright, anyone have any questions about how to do that?
What are you doing right
We're gonna practice. Alright, you're gonna practice. Look over on page 59. We're gonna start with number 1. So according to the following reaction, how many moles of ammonia, good, I didn't erase it. How many moles of hydrogen are needed to produce 4 moles of ammonia? So I'm starting off with ammonia. Wait. I'm starting off with ammonia. So 4 moles of ammonia, and I'm going to hydrogen. So don't just plug it in. So we're starting off with ammonia. Alright, so try to work it by yourself, and then I'll help you out.
Alright.
I already got it.
You already got it? Let me give over to the
All right.
section then.
Hold on.
Hold on.
I got it.
Alright, how many moles?
6.
Good job. Alright, because we're basically working it backwards. So 4 moles of ammonia. How many moles of ammonia according to the concentration?
2.
Alright, so moles of ammonia. How many moles of hydrogen?
3.
Good job.
I said backwards, that's all.
That's fine, just be careful. So 4
4
times
divided by
3 divided by 2 equals 6. Or you could have just said, if I doubled it, then that means this one has to be doubled. That also works as well.
4
Alright,
times
number 2.
4 times 2.
4 times 3 divided by 2.
Yeah, I got that.
Alright, number 2.
Number 2. Okay.
How many moles of carbon dioxide will be produced in the combustion of 0.6?
Combustion?
Combustion.
I like that word.
It is reacting with oxygen with fire, typically. And then it gives you the following reaction that's already balanced.
So 5 into 6 is total. Okay.
Alright, so looking at that substance, what substance are you starting off with? Looking at the equation in number 6, what substance are you starting off with?
Carbon hydrogen.
Alright, it's asking you how many moles of carbon dioxide will be produced if you work with 0.6 moles of pentane, or the C5H12. Alright, so what am I starting off with?
1. Oh, 0.06.
0.6 moles of, what is this? Pentane. Alright, according to that reaction, how many moles of pentane do I need to
8.
I think you're looking at
I'm on the
oxygen.
wrong one. Wait, am I? What?
How many moles of pentane?
1.
1. If you're already done, go on to 3. Alright, and then how many, alright, I'm going from pentane to carbon dioxide. So according to that reaction, how many moles of carbon dioxide do I get?
5.
Good job. So 5, that's 2. Alright, and that'll give, so it's 0.6 times 5 divided by 1.
Three.
That's the same idea. What?
3.
Is it?
Yeah.
Type in your calculator.
It's 3.
It is 3. Is that what you got, Chris? What'd you get for your answer? Did you write down? Type it in then.
Number 3, where's the?
Alright, there's part A and then there's part B.
Oh. I got 43.
Alright, so you're starting off with 0.6 moles. Now, for every mole of this substance, there's 1 mole for every 5 moles of carbon dioxide. You're going from pentane to carbon dioxide. That's what it's going to look at that balanced equation. So it's 0.6 times 5 divided by 1.
3.
3. There you go. Alright, any questions about how to solve that? Alright.
So it has to be 3. It just has 1, so that's what we're gonna put.
Alright, wait. Read part A. If a chemist has 1 mole of hydrogen and 1 mole of oxygen to react, according to the equation above it, which one is a limiting reactant? So that's all you're asking, just that first part, figure out, okay, which one is which? Alright. Hydrogen, why?
Hydrogen, because hydrogen uses 2.
Yeah, so if I only have 1 mole, that's it. So hydrogen for part A is right off that bat for that one. Alright, letter B, how much? I almost said dihydrogen oxide. How much water could be produced from 1 mole of hydrogen and 1 mole of oxygen? So let's say, poor scientist just decides, whatever, I'm just going to work as much as I can with it. So, the reaction for this one, alright, but I'm starting with, it's asking how many moles of water. So, I'm starting with 1 mole of hydrogen and 1 mole of oxygen. So, hydrogen is a limiting reactant, so we're going to focus on that one. I'm starting with 1 mole of hydrogen. How many moles am I supposed to have to get how many moles of water in this?
Just have 2 to get 2 moles.
Yeah.
The answer is.
Alright,
Yes.
so,
Yes, I do.
what would this be, right?
1.
1. So basically, you cut the reaction in half. Alright, anyone have any questions about how to solve that? Alright, so this is, alright, go ahead and get your time pads for the homework because this is to help get you started for practicing for reviews. So, your homework is going to be on page 59. You're going to answer, you're going to do number 3 and number 4. You're not done. So 3 and 4 is your first set. To help get you started for your exam, you're also going to do on page 48, you're going to do 2, 4, and 7.
That's it?
Yes.
That it?
No, I'm saying is that like can I pack?
Yeah, you can back up. Alright. So it's 3 and 4 on page number 59, and then 2, 4, and 7. It's a lot, but it's to help get you ready for your exam. So it's fine. Just pay attention to what you're doing.
Can I get 100 on my quiz?
I didn't finish.